everybody. So this is the continuation of my video series on describing distributions. Remember, to describe a distribution, you need some sort of graphical display. Once you have that, you're going to go through SOCs, describing shape, outliers, center, spread. So we've already taken care of shapes and describing those. We've done outliers. Now let's talk about centers. So depending on what graphical display you have, centers can be a little bit tough because the two ways we describe centers right now are means, which is you need every single data point, add them all up, and divide by the total amount of data points, or medians, which is finding, you have all your data lined up in numerical order, finding that exact middle data point. So half the data is below, half of it's above, that exact middle data point. And if you're stuck between two of them, you average those two. So let's talk specifically with stem and leaf plots, histograms, dot plots, and box and whisker, because depending on what you got, again, you can't do both of these, okay? So stem and leaf plot, just a real basic one here. I have a whole bunch of stems, leaves. Keys tells me that if you see a stem of 3 and a leaf of 5, that's going to represent 35. So on this one, I could do a mean if I wanted to. I just need to add up all the data points. So I'd be doing 14 plus 22 plus 22 plus 35 plus 39 plus 42 plus 44 plus 46 plus 48, 51 plus 57 plus 57 plus 59, 62, so on and so forth, and divide by the total amount of data points, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I could totally find that mean. That is possible. So for this stem and leaf plot, since I can see these specific data points, I can do a mean here if I wanted to. Now a median, remember, an easy way to do a median is if you know the total number of data points, you add 1 to it and divide by 2, that is going to tell you the location of the median. So then you just count through and find that spot. Okay, it tells you the location of the median. It's not the median itself, it's the location. So for this one, I had 16 data points. I know median's pretty basic, that's why I didn't calculate it. If I wanted to find the median of this, there's 16 data points. So I would have done 16 plus 1 divided by 2. So that's 17 divided by 2. That's 8.5. Meaning I need to look, if I have all my data points in order, I need to look between the 8th and the 9th data point. And that is my median. So I will be able to do this. And just because median's a little bit more of a foreign topic to you, we could go ahead and calculate it. So if I'm counting through, this is my first data point, so I'm going in order. 14 is my first, second, third, fourth, fifth, sixth, seventh, eighth. So 46 and 48 is my 8th and 9th data points in a row. So since I'm stuck between 46 and 48, I'm going to find the average of 46 and 48, which would be 47. That would be the median of this data set. You'll see that there's 8 data points above, 1, 2, 3, 4, 5, 6, 7, 8, 8 below, 1, 2, 3, 4, 5, 6, 7, 8. The median finds an exact center. So for a stem and leaf plot here, yes, totally can find the mean, can totally find the median. Let's talk about histograms. Histograms gets a little bit tougher because depending on what type of histogram you have, and I know these are pretty sloppily drawn, depending on which one you have, you can sometimes calculate the mean. Sometimes, but not very often, but you can still always calculate the median. So mean is sometimes, median is all the time. So I'm going to show you one time where you can calculate the mean, and then I'll show you a time where you can't calculate the mean, and then we'll talk medians, which works no matter what. So on this left histogram, my classes are just 1, 2, 3, 4, 5. So I have a frequency of 1. So I have 1, 1. When I look at the 2s, I got 3 of them. So my data set is going to have 2, 2, 2. When I look at the 3s, I got 2 3s, 3, 3. When I look at the 4s, I got 4 4s, 1, 2, 3, 4. When I look at the 5s, I got 1 5. So I'm able to see on this one, just because the classes are a size of 1, I'm able to see and know the specific data points. So I know there's a 1, a 2, a 2, a 2, a 3, a 3, a 4, a 4, a 4, a 4, and a 5. So I could add those all up and divide by the total amount. So I could totally calculate a mean there if I wanted to. Now a median, remember we're going to use this same idea here. This is the key here. Find n plus 1 divided by 2. I need to just figure out how many total data points do I have. So let's ignore these numbers inside the boxes. If I want to know how many total data points I have, just count the frequencies of each one. So I had a frequency of 1 here, a frequency of 3 here, a frequency of 2 here, frequency of 4 here, and a frequency of 1 there. So I have 1 plus 3 is 4 total data points, 6 total data points, 10 and 11. So if I wanted to find my median, that was 10 total data points, so 10 plus 1, divide by 2. And what I would get there, wait, is that, nor did I say 11. What was my count here? Sorry. 3, 4, 5, 6, 7, 8, 9, 10. Oh, sorry, it's 11. So 11 plus 1 divided by 2. So I'm going to find the 6th data point in line. So here's the first, second, third, fourth, fifth, sixth. I would know my median is in 3. Okay, so I can totally do a median here. Count up the frequencies. So I just write right above the bars there. Count up my frequencies of each. Count up the total amount of frequencies. Take n plus 1 divided by 2 to find what is the position of that median. And then just count through until you find that position. You have yourself a median. This second histogram changes things a little bit. Okay, so I'm going to show you why all of a sudden mean is an issue. So my class has changed from 10 to 14, 15 to 19, 20 to 24, 25 to 29. I still know by my frequencies that I have 2 numbers in the 10 to 14 range. I know I have 2 numbers, but the issue is I don't know what those numbers are. I don't know if I have a 10 and a 10, a 10 and 11. I have no idea. I just know there's 2 numbers that exist in the 10 to 14 range. So if I don't have the specific numbers and data points, it's going to be very, very hard to add them all up for a mean. So on this type of histogram, it is impossible. It is impossible for me to calculate a mean. I just can't find the individual data points. If I don't know the individual data points, we're no good here, okay? But I can calculate a median because I know there's 2 data points here. There's 4 in the 15 to 19 range. There's 3 in the 20 to 24 range. And there's 1 in the 25 to 29 range. So if I look at that total there, there's 2. That's a total of 6, 7, 8, 9, 10 total data points. So if I'm looking for location, 10 plus 1 divided by 2, I need to find the data point that's between 5 and 6. The data point between 5 and 6. So there's 2 here, and then there's the 3rd, the 4th, the 5th, and the 6th data point fall in here. So my 5th and 6th data point fall in the 15 to 19 range. So I can't tell them specifically what that median is, but I could say, hey, I know it's the 5th, 5.5 place in line. So it's between the 5 and the 6th. Both my 5th and 6th data point fall in here. So it's in between the 2 in here. So I know my median is in the 15 to 19 range. So you can still calculate a median no matter what type of histogram you have, but depending on the classes, it might be impossible to calculate a mean since we don't know the specific values of these data. So last 2 graphs, dot plot. For this one, we can see, because of individual values, we can calculate a mean here if I wanted to. I know I have a 10, a 10, and a 10, an 11 and 11, a 12, a 12, a 12, a 12, a 12, a 13, 13, so on and so forth. So I could take each of those numbers, do 10 plus 10 plus 10 plus 11 plus 11 plus 12 plus 12 plus 12. I could add all those up. I could totally calculate a mean there to find the center. The median, I can also calculate that as well. All you really need for a median is you need to know the total amount of data points. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 data points. So I do 16 plus 1 divided by 2, which says, hey, find the 8th and the 9th data point. It's in between those. So count in order. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's between that 12 and that 12. Well, guess what? Your median will be 12 there. Okay, so you can still calculate a median there. No big deal. Could still calculate a mean there, but not always. And then finally, we have our box and whisker plot. Okay, our box and whisker plot. So when I'm talking about center, with the mean, I would need to know every single data point. Every single data point, and I would need to know the total amount of data points. Okay, so with a box and whisker plot, I know some of my data points, but I don't know all. I could figure out what my lowest data point is. I could figure out what my highest data point is. But beyond that, these Q1, the median, and Q3, those could be averages. I don't know if those are actual data points. So I don't know every single data point, so I cannot do the mean on a box and whisker plot. But then when you think about median, you need to know how many total data points there are. But with a box and whisker plot, there's two things to kind of think about here. One thing you also don't know with a box and whisker plot is I have no idea how much data, what's the total amount of data points there are here. All I know is percentages of data. I know 25% of my data falls in that little section right here from my minimum to my Q1. I know 25% of my data is from Q1 to the median. I know from the median to Q3 is 25%, and I know from Q3 to the max is 25%. As far as how much data is in there, I don't know if there's 5 data points in here, there's 10, there's 200. I have no idea. So that's kind of important for a median to know your total amount of data points. So you would think you're stuck on the median, but we'll be okay. The median on this one is super, super easy to find out because the center of your box for your box and whisker plot is always, always, always the median. So all you would have to do is say, all right, well, there's my median. Where are we at with my number line? It looks like my median is 20. So on box and whisker plots, cannot do the mean. It's not possible, but you can do the median. So you'll notice there's a few differences depending on the graph you get. Sometimes you can do a mean, sometimes you can't. Okay, so you got to be careful. One thing that you can always do, no matter what type of graph you get, is you can always, always, always calculate the median. So that was how to describe the center of a distribution. Only one more topic to cover in describing distributions, and that is spread.